Good morning, everyone. It's a nice, really nice crowded room, but I'm going to change that when we start. Who is here for microservices, like Kubernetes, auto-scaling, all of those things? I hope no one, because that's not what this talk is going to be about. The idea for this talk is to talk about how we built JetBrains Rider, our IDE, coming from a model where everything is in one process, we run everything in one place, to expanding that across multiple processes and all of those things. So if you're interested in that, absolutely stay. If this is for Kubernetes and all of those things, there might be other talks here. With that, let's get started. So first of all, who here is currently using Rider? A lot of people. Good, thank you. For those of you who are not yet and have no idea what it is a full-stack .NET IDE, works cross-platform. It is lightweight-ish, I'll call it that, to be honest. And it helps you to be more productive as a developer. Slides are nice, but I'll go and give you a really quick demo. So Rider is an IDE. So what you expect from an IDE, you have a solution explorer on the left where you can browse files and open files and all of that. You see code opening up. You can write codes. So for example, I can create a new class called person, let's say, and in that class I can start adding properties. All of those things are in there. I can go in here. There's refactorings and all of those things where you can change things into using backing fields and all of that. Not only coding, there is Git tooling. There is an endpoints view where you can actually see which endpoints are in your ASP.NET application, for example. There is unit testing, a terminal, a really nice Nuget client as well. There is a database tool window that I think a lot of people miss out on. It is one tab on the right-hand side, but it's really good to work with databases and all of that. And yeah, I think that's pretty much the quickest demo I've ever done about Rider. But just to give you an idea, it's an IDE, right? Cool. Before we dive into the technical side of things, I want to give you a brief history about JetBrains and the IDEs that we have been building. So a long time ago, 20 years ago, we built this fantastic, nicely designed Java application called IntelliJ Renamer that you could use to rename your classes and files in Java applications. 20 years ago, this was something novel, something that didn't really exist in a good way. It allowed you to make changes to your codes without breaking the code, making sure that it kept compiling. If you renamed the class, all the references would be renamed and all of those things. Now, obviously, this has evolved from this very simple tool to something more. And over the years, we have been building more and more IDEs, more and more products. So we started with Renamer, became IntelliJ a full proper IDE a bit later on. Then in 2004, I think Eclipse was released in the Java space. So we decided, okay, let's not bet on one single horse that is IntelliJ for the Java space. Let's also come with something for .NET. So we built ReSharper, and by now we have 20 plus IDEs and all of those things. Now, ReSharper is interesting. ReSharper actually also started as something we did not know what it would become. We thought, okay, should we build our own IDE that is a competitor to Visual Studio, which is what you see here. We actually built it in WinForms, and it's pretty amazing to see all of those things in the editor built in WinForms. So this was created, but we did not yet know whether we would ship this as a full-blown IDE or go with a plugin model that we would have a plugin to Visual Studio that you could then use in your favorite IDE back then. Turns out that we did not ship this one. If you're interested, I think you can still download it somewhere on the website. It's horrible to use, but it's there. But having that distinction between are we going to ship a full IDE or are we going to ship a plugin actually forced us into making some choices in how we would build this IDE. The project was halted, but not everything was removed. So if you look at the screenshot here, if you're using Rider today or ReSharper today, this find usages dialog it's been modernized a little bit, but it's still pretty much what it was back then. The fact that you have a solution model and can look at all of those things, that has all been retained and is still in the plugin that you today have in Visual Studio. So we decided to ship a plugin for Visual Studio, but also keep this distinction between all of those different models that you could use. So that's why we also have, for example, the ReSharper command line tools. If you want to run code inspections and all of those things, you can run those on the command line. It will spin up this essentially the same engine, do the inspections, look at your codes, and see what is going on in there. So a lot of this architecture of this first IDE that we built with ReSharper has been retained over the years and is still there today. Now, interesting is that over the years, also a lot of people have been asking, like JetBrains, it's nice that you have ReSharper as a plugin, but when will you build your own .NET IDE? And actually, this is a NDC London booth where we had that question a lot in the past at different booths. But this question came about, and also .NET Core came about. In 2017, we got that question. We saw that Roslyn was coming. Visual Studio was getting a lot of memory pressure and so on because of its 32-bit architecture, which, by the way, in VS 2022 is much, much better. And changes impacting ReSharper, Visual Studio changing the product, the plugin model a little bit. We had some issues with that, and we were impacted by that. .NET Core came about as well. There was no really good, consistent cross-platform .NET IDE, so we thought, okay, let's make the jump. We have this experience, we have these components. Let's see if we can actually make this come true, build our own .NET IDE that is cross-platform. Now, cross-platform also means that you will need a UI for your cross-platform application. All of the ReSharper UI that sits in Visual Studio is all WinForms or WPF. And that is non-existent on Linux or Mac, for example. So we had to think about, okay, can we leverage what we have there? Can we take what we have there and convert this UI to be cross-platform? So we started looking at, can we run Mono and WinForms maybe on Linux and Mac? Can we rewrite everything in Qt, for example, and go with that as the front ends? Turns out all of those were not really good ideas because they would essentially require a full rewrite of everything that is the UI of ReSharper, of this IDE. But we started thinking, we have IntelliJ, our Java IDE. We built all of these other IDEs on top. It's already cross-platform. Can we maybe leverage this IntelliJ platform to build Rider with? If you don't know, all of our IDEs come from the same platform, the IntelliJ platform, that is open source. If anyone here is doing Android development, for example, you will see that Google actually took that IntelliJ platform IDE and built Android Studio on top of that. There's a couple of other examples. I think there's a Perl IDE out there as well, based on this one. There's Comma IDE. I think that's actually the Perl IDE as well. There's a couple of IDEs built on top of this. If you want to build your own, you can do this. It is already cross-platform. It comes with a terminal, with Git, with a lot of the basics that you expect in an IDE. So if you want to build something for your own custom language, you can do that if you want. But we saw this, and we thought, OK, let's maybe see if we can reuse IntelliJ with Rider. Now, IntelliJ and ReSharper are built in different technologies. ReSharper is all .NET based. It runs .NET. All the inspections, the C# language model, all of those things are .NET. And IntelliJ platform, on the other hand, is JVM. It's Java based. It's built in Kotlin, Java, and a couple of other things, but it's not the same platform. So there was no way to take ReSharper and just run it in IntelliJ because they are different. So we started thinking, what can we do to solve this? How can we bridge this gap between having this .NET code and this Java code on the front ends? And being JetBrains, we like playing with codes. And we thought, well, let's maybe create a tool that converts all of this C# code that we have in ReSharper into Java so we can run everything in IntelliJ. Bad idea, didn't really work out, so that's definitely a no-go. Then we started thinking, OK, we have ReSharper running as a command line tool as well. Can we maybe use that and then set up some mechanism to talk to this command line tool to get this information, to get that project model, and plug UI on top in IntelliJ? Should be simple, right? Well, it is kind of simple. Having ReSharper as that backend is fantastic because .NET runs cross-platform. If you don't need the UI, you can just run this on Linux and Mac OS and all of that. And we could reuse our .NET code in ReSharper. Rider is essentially 95% of the ReSharper code base plus some Rider specifics. IntelliJ as the thin UI on top seemed like a good idea as well. We could just plug that on top of this .NET process, control the process, maybe restart it, give it parameters to load a certain solution, all of that, so seemed feasible. Well, it was not that feasible, actually. IntelliJ is not really a thin UI. It is a full IDE that has Git support and all of those things, has its own editor, has its own refactorings, all of that. And we started thinking, well, we actually have two IDEs now that have to talk together and do things. It's not just a UI and a smart backend, it's a smart frontend and a smart backend that we had to bridge. And if you look at Rider, you will see there's actually three sorts of features. There's those that are handled completely by the UI, by IntelliJ. If you work with Git, for example, look at the history of the Git tool window. That is going to be IntelliJ. If you write codes, that is going to be a combination of the two, where IntelliJ renders things, ReSharper does things in the backend, gives you completion, IntelliJ can apply those things and all of that. But there's a couple of cases where this really fits together if we could use the smart tools from both sides of the equation. So let me give you a quick idea of what I mean with that. If you look at Rider and you open up, let's say, a HTML file in there, I'll go with a random file in this project, I have no idea. You will see that a typical HTML document is actually multiple languages. You have HTML, but you also have CSS that it has to understand. If you want to navigate to this main CSS class, you can jump there and get that information. So all of this is two languages in one document. All of this is handled by the front end, by IntelliJ. Now, things become more interesting if you look at, for example, a Razor file, where you have, let's open this one, I have no idea, where you essentially have HTML, you have CSS and all of the understanding of the CSS that is going on there, but you also have blocks with C# code in there, or VB.NET if you want to use VB.NET. So you see, things get more complex because the HTML here is all handled by front-end IntelliJ smartness, but the C# code is handled by ReSharper. So you have to really be able to essentially have small islands of C# code inside of documents that work in the front end, right? Things get more interesting if you start adding JavaScript, for example, or with Blazor, where some of the Blazor stuff is ReSharper, some of the Blazor stuff is IntelliJ. So it gets complex really quickly. But the nice thing is, if you have those islands of C# codes in documents that IntelliJ handles, or you have islands of whatever language in the ReSharper stuff, you can do really cool things. So for example, if you look at one of the controllers here, I set up a database connection to a database somewhere, and if you use Entity Framework, and I should have a query somewhere. Let's go with this one. If you just write any SQL string, let's say var SQL equals something, where we write select star from whatever, you get completion from the database. This is really cool, because I'm editing a document in IntelliJ frontends. The C# and all of that is handled by the ReSharper backends. The database connection is handled by the front end again, and you sort of have to bring all of those things into one place where you can work with this database tooling, for example, and get this completion where you can also Alt-Enter and see suggestions from ReSharper, but also from the front end that say, for example, you can run this query in the database tooling if you want to. So things get really, really complex really quick if you start combining the two smart IDEs on both sides. Which is where we started thinking, how can we make the two ends talk? How can we make this vision come true where we have those two things working together? So if you look at just some examples, if you look at context actions where you Alt-Enter and you get this nice pop-up where you can do actions, typically you have IntelliJ rendering the text, the carets that is there. If you use multiple carets, you can do that as well. The Alt-Enter key binding is also IntelliJ. And IntelliJ also has a language infrastructure where if you are typing, it will ask its model, like, what language is this and what can I provide? Then we have ReSharper, picking things up, looking at the language, parsing everything, making sure that we have inspections and actions available, and then IntelliJ renders those. Sounds complex, but if you start thinking about it, the data that has to go over the wire between the two processes is actually fairly simple. You have a tree of items you want to show in that menu, maybe with a description, an ID, a name, icons, whatever you want to pass there. No logic is needed. If you just have an ID for this rename to option name, for example, you can pass that ID, and if you click it, we can pass that ID back to ReSharper and execute that action if you want. Same thing with inspections. If you look at the codes, a lot of stuff is handled by IntelliJ, a lot of stuff is handled by ReSharper, and the two talk together. And there's a lot of things happening on both sides of the process. But if you look at the data, it is really, again, just a set of names of the inspection, what is going on there, what are suggested actions that you can take, maybe with an ID and an icon and a name, and the text range to which this specific suggestion applies, right? What is interesting is the data is simple, but the communication model is not simple. You cannot really do RPC. You cannot type something, send requests to ReSharper, and then wait for them to come back to show something, because you will probably be faster than anything that we can do in terms of technology there. So we have to make sure that the editor keeps responding while you are typing, while you are invoking things. But the data itself, the context that you have to provide to make something happen is not that complex if you think about it. Writing code actually is a more interesting one, because there can be multiple parties writing code. You as a human, you are writing code and you are typing, but maybe you are invoking a rename refactoring that takes 500 milliseconds to execute, but you're already typing while that rename refactoring is still going on and is being applied to your editor, so you really have multiple parties writing code in the editor. It's difficult in terms of having this model of having multiple parties writing code in this case, but if you think about the data that has to go over the wire, again, it is fairly simple. It's a delta where you say, in this document, on this line, on this character position, we changed this into this. Please update this in the editor, if you think about it. So the data types are not that complex, and if you start breaking them down to these small generic samples of how you can do inspections, for example, it actually becomes really easy to make all of the inspections work. If you can get one to work, everything would work at some point as well. Then we started thinking, which protocol do we use? How do we make these two processes talk? We know what the data format could be, but how do we actually set up that connection? How do we bridge this gap between the two processes? Back then, Visual Studio Code was at that point, I think, 3 years old. They implemented the language server protocol, LSP, which is brilliant. It does what it does for VS Code, but it is also very VS Code specific. We looked into it, and with the model that we have in our IDEs, LSP would either need a lot of extensions, which would be kind of crazy because we would extend it so much that we were essentially building our own thing anyway. So we decided, okay, let's not go with LSP for our tools. Let's build something custom. Let's look into what we can do for the model that we have in both sides of the IDE. So we experimented with lots of things. Very simple .NET HTTP server sitting in ReSharper where we would send requests, get responses, and do something. Try JSON serializers, protobuf, custom binary protocols, all of those things, but always in a request-response style, much like a language server protocol would do as well, where we would send messages and get responses back and do something in the IDE. Well, turns out that request response is not that optimized in an IDE where you have two sides of the IDE that are providing features to the entire experience. We realized that having request response was actually blocking us. How could we make this better where both parties could at the same time do things to your code base, to the model that we have from the code base, where we can share those things in memory and share whatever is going on there? So we decided, okay, maybe request response is not okay. Maybe we should look into model view model. What you would have in mobile applications, for example, a lot of people are using this. You have a model, you subscribe to this model, you push messages into this model, can be from any site, and you just update based on whatever is going on there. You have an observer pattern looking at new files being added, for example, where you can open up the editor, where you can start scanning the code, parsing the code, all of those things. And essentially, we decided, okay, it would be nice if we have this model where you can just say, you have a project has files, we add a new file with contents or whatever. For a specific file, we have inspections, we want to add a new one with the description, with the icon, with the category, and what the text range of those things would be. And both the front end and the back end could subscribe to this and do something with it, just react to whatever was going on. Sounded interesting, proved to be challenging as well, but it works. There is one big downside, though, and that is conflict resolution. Looking again at that refactoring example where you may be typing while ReSharper is refactoring and applying that code change, how do you solve conflicts? If I rename my person class into something else and then I start typing, but then ReSharper updates that person class, who should win? My latest changes that I was typing or this refactoring that I maybe executed 2 seconds ago? What should win? So we started looking at how to solve this, and the typical example there would be, well, we can just lock. If you do a refactoring, we do this modally. We wait for the refactoring to complete. We lock everything, and then only then when that completes, you can continue. Well, not ideal, because those locks may take a second, 500 milliseconds. It's really noticeable if you are typing, and it really gets in the way. So we started thinking, can we simplify this? And we came up with optimistic conflict resolution, where every change in that view model gets an internal version number, and the latest version essentially wins. So if you start typing and ReSharper does a refactoring, if the refactoring has a newer version than the code you are writing, then we apply the refactoring. If you are typing, those changes will have a newer version, so the refactoring will not go through. So really just essentially the latest change wins. And this turns out to be a really good model that works in this model. Cool. So let's talk about the protocol. We talked about the concept so far. Let's talk about the protocol. Essentially what we were trying to achieve was this, where we have Rider built on the IntelliJ platform on the JVM, ReSharper on .NET or Mono back then on macOS and Linux, and have something sitting in between that does the communication between both parties. One additional requirement, though, this model, our developers should not all know all of the tiny little details of this model. Ideally, they would just go in there, build a feature, and not have to think about this conflict resolution, for example. Have all of those things in the protocol so they would not be confused or spending time on fixing those things. Just create view models, subscribe to them, push data into them, etc. So we came up with the Rider protocol. It's a reactive distributed communication framework that currently runs in a lot of languages, .NET, Kotlin, JavaScript, C++. It is open source, and essentially the idea there is that we have the entire protocol taking care of pretty much everything up until that model definition DSL. You as a developer write that model definition, generate code from it, and you just work with it from Kotlin or from .NET or whatever you want to do. And everything in terms of primitive types, in terms of conflict resolution, in terms of actually having a socket connection between the two processes is handled by the protocol. So if you're interested, definitely give it a try. It's very opinionated, of course, to our use case, but it's kind of cool to work with in other things. So developers would only need to know about the data types and the model. The codes would be generated based on that model, so you could work with that, and you would not have to think about anything. Also, nice thing about code generation is that everything is generated. It's already there. So there is no JSON serialization, deserialization going on, no reflection going on. It's really hard-coded to, this is the model, this is how it goes on the wire, and this is how it works. The protocol also has hierarchies and lifetimes, and that deserves a little bit more explanation so you know what is going on. But first of all, let's look at the primitives in the protocol. If you want to communicate between two processes, what you will need is simple types where you have strings, booleans, lists maybe that you can add data into. You want to have signals where you can say, look, this is happening, please respond to this. You want to have properties where you can make a change to a property and you get change notifications so you can update the UI or the backend process and all of those things. The protocol model is built on top of those primitives. So what you will see is, for example, that you have this RD Nuget host object that extends the solution model, where you see that we have an inner type that is a struct definition, a struct essentially that has two fields, a timestamp and a text. And we model everything like this. You describe what you want on the wire, what the view model should look like. Next thing that happens is we generate code on that. Now, all of those primitive types have fairly simple implementations. The big one that is in the RD protocol is signals, where you have an event happening and you want to respond to that. And essentially what we have is an event source that can fire something has been changed, for example. And we have a sink that can then listen to things, advise on actions that should happen when something goes on there. The interesting thing you may see there is this lifetime parameter, and that's one of the next things we will talk about. Lifetimes are important. In an IDE, you have multiple tool windows, you have multiple things going on all the time that all look at the same thing. So it's really difficult in an application like this to work with disposables, to do proper memory management, where you say, okay, I'm using this file stream, for example, changing these documents, because there's so many things looking at those documents. So instead, we work with lifetimes. So what happens is, when you open up your project, or on the ReSharper side, you open up the solution, we start a project lifetime. Everything that happens from that moment on also subscribes to this project lifetime. So if you open up the Nuget tool window, that subscribes to the project lifetime, but also comes with a Nuget lifetime. If you open up a new tab in the editor, well, we subscribe to the lifetime of the project, but also to a new lifetime that is specific to this editor tab. Having those lifetime objects means that if something has to go out of memory, we can say, okay, look, everything that is this editor tab and below, dispose yourself. Same thing if you close the solution, what happens is the project lifetime will be disposed, and everything underneath it will also be disposed, and we get rid of all of those things. Interesting thing here is that we have that lifetime on both sides, on the ReSharper side and the IntelliJ side. So the protocol that you saw in this signal on the slides is also taking care of those lifetimes, making sure that if you close the project in IntelliJ, that we also close the solution in the ReSharper side, and all of those things, of course. So the lifetimes, it sounds complex, but it's actually fairly simple if you look at the base definition of the lifetime. Lifetime is essentially a disposable of its own. It has a stack of resources that it can dispose of at some point. And when you attach to it, we just push an action on the stack that should happen when this gets disposed. And when it is disposed, we just walk that stack and close everything that was hanging underneath. So fairly straightforward, I would say. This is, by the way, its own separate Nuget package if you want to play with this in your own solution and not use typical disposables and work with this lifetimes approach. We have open sourced this one. It's really, it's a bit more code than what is on the slides, but it's very simple, actually. Cool, so let's look at the protocol. Where is my IntelliJ? All right. So I have opened, I think, last week's nightly 2021.3 version of Rider branch, and you will see that the solution that we have is IntelliJ-based, where we built the front end, but it is also ReSharper-based, so where we built the back end. So you will see both IntelliJ and Rider working on Kotlin code for the front end and working on .NET code for the back end, right? Cool. So I was talking about this Nuget model. Let's maybe take that as an example. So let's go back to using Rider, just looking at what is going on. If you go into the Nuget tool window and you want to install, for example, a new package or upgrade something, you can do this. And you will see that there is a, yeah, it's fine, override it, it's good. You will see there is a log tab where lots of things are being emitted in terms of what is going on in this Nuget operation. So let's look at how this log was built in Rider and in the protocol. So to get this, we first of all needed to set up a model, and I should take the right IDE. So the model of our Nuget host in Rider is this. This is the model DSL that we built. We have a Nuget host. It has lots of things, but it extends our solution lifetime. It hangs off of the solution. We have different things like version constraints, all of the things that you can set in terms of Nuget. There's a package identity that has an ID field, a version field, and so on. And at some point in this file, I will have a log message, the thing you just saw scrolling by in the UI. Log messages have a timestamp. They have a context. Is it coming from Nuget, from Rider, or from MS-Build? This is an enum definition in the protocol. It has a level, another enum, where we can distinguish between, is this debug, verbose information, all of those things. And then the actual message that is a property called text. It is a field of type string. If I want to make this nullable, for example, I can add .nullable, and it will be nullable when we regenerate this, the code from the model here. On the front-end side, so IntelliJ side, this model is then compiled into Kotlin code. So what you will see is that our model is really big, generated code, and it's actually pretty ugly if you look at it. But what you will find is that there is this log message class in Kotlin based on what we designed in our DSL model, and it has a timestamp with a Kotlin date property. It has a context with this log context enum that we also modeled in the protocol, and it also has text, which is of type string. So design the DSL model, generate code, and then from then on you can just work with all of the classes and all of the fields that are in here. Back in our model, you will also see that this RD Nuget log message is being used in a, where is it? Yes, in a sink that is called log, and that is a list of log messages. So in our model definition, we say, okay, look, we will have a collection of log messages. You can write into it. It should behave like a list when you work with it. Again, looking at the Kotlin code, you will find that there is a log. Where is it? I can't find it. Perfect. Ah, yeah, there it is. So there is a log property that we named in our model, and it is a list of messages. And we can just work with this log property and start adding messages to it, and UI can subscribe to it, but also the backend can subscribe to it. On the ReSharper side of things, the same thing happened. This RD Nuget host was also generated as a C# class file based on the model that we had. We have this log sync there as well. That is a list of RD Nuget log messages, not Kotlin RD Nuget log messages, but actual C# code where you also have a timestamp, datetime property, where you also have this context enum that was generated, and all of those things coming from the model again. Everyone with me still? Good. Now, how does this hook up? Well, in Rider, we make use of Microsoft's Nuget code as well. And what we do to get log messages is we implemented our own Nuget logger, extending the one coming from Nuget proper, plugging it into Nuget proper. And whenever Nuget itself logs something, we essentially call into our host in log. We fire that in our collection, we want to have a new Nuget log message. That is everything going on here, essentially bridging Microsoft's Nuget with our protocol. We add messages to this list. And on the front-end side, let's go to the front-end side again. On the front-end side, we have some UI, where in that UI, we listen for changes to that list. Where is it? Nope. Nope. No. Where is it? Oh, man. There have been some changes lately. I'm in the sources panel. That's, of course, not the logging panel. I should be in this one. Right, so in the logging panel that we have in the UI, you will see that whenever you open up the UI, we first check the full log of messages that are already there to make sure that we can populate something, and we just add them into the UI. What we also do is that at a later point in time, when this panel is created, we also subscribe to this list. So we subscribe to our log lists. And whenever new messages come in, we also add them to the UI. So this is a subscription to what is going on the protocol and what is going on and happening there. Again, the lifetime pops up here. So we only listen while your solution is open, while the Nuget tool window is open, and all of those things. If one of those things gets disposed, this thing will call its dispose, and we also remove all of the listeners listening to whatever is going on in the protocol. Still with me? Good. So this was an easier example, but as you can see, the idea is that you only have to care about having this protocol, writing the protocol model, generating code, and from then on, it's essentially working with the primitives that are there, subscribing to something that is going on, and passing along objects in the language that you are used to working with. You don't have to care about conflict resolution or serialization or whatever is going on. It is just there. I'll show you another example later in the talk as well. Right, so Rider protocol, the good thing is the DSL that we have for defining your model is all Kotlin-based, which means that we have an IDE for Kotlin, so you get completion for all of the primitives that are in there. It's also fairly simple for our devs to work with it, update the model, regenerate code, and start working with it if you want. It's very simple to find something in the generated C# code, for example, and trace it back to the model to see where is this class or this object coming from. Lifetimes are there. You don't have to think about anything going on the wire. It's cross-language, cross-platform, so if you define the model, you can generate it towards Kotlin, towards C++, towards JavaScript if you want. So if you want to build a UI on top of Rider that is browser-based, I would not recommend doing it because you will have to implement a lot of things. But in theory, you can do this. You can generate this code and build something in JavaScript if you want. The downside of this entire model is that there is some added complexity for anyone who wants to build a plugin for Rider. And I've been building a couple of those. And it is indeed a bit more complex because you can either have a plugin targeting just the front end, just the backend, or you have to dive into the protocol as well to get your plugin components sitting in the front end and the backend to talk to each other. So that's the big downside there. Right, let's talk about what you came here for, microservices. By definition, Rider is already an IDE that is based on microservices because you have two processes doing part of the work, they communicate with each other, and they do something. So we have front-end process, back-end process. Really nice because they are isolated. Things can happen, things can change, and they run independently. They have their own memory space. They have their own garbage collection, which is also interesting because the UI may be pausing while the backend is doing things. But in theory, shouldn't matter. You have two processes running, and you have those separate things. It's really nice on multi-core machines because front-end and back-end could, in theory, run on different cores and all of those things. And you can even start and stop both sides independently. Actually, if in Rider, you just imagine we just started Rider, you will see this welcome screen of projects that are there and what you can do. At this point, we essentially take what we learned from your environment, show the project templates that are there, but at this point, it's not guaranteed that ReSharper has already started when you start creating a project. So we launch them when needed. Debugging is another place where we have multiple processes running together. You have Rider, which is IntelliJ and ReSharper again, but we launch your application, and we also launch a debugger process looking at what is going on in your application. We have the view model shared between IntelliJ, between ReSharper, between the debugger process, and everything that we can gather from your project that you are running from that application. So this model can be shared between all of those processes, and they can all contribute to the information that is there by adding something to a list or sending a signal or doing something with what we just saw in the protocol. That's also interesting, having this approach of having multiple processes, and it got us thinking. Can we do more than just those basic processes that are front-end, back-end, and a debugger process? And yes. We started thinking, can we maybe have some features be their own process? If you do WPF, for example, in Rider, you will actually have yet another process running. The preview that you see on the bottom there that renders your WPF application is a separate process that is started only when you have a WPF project open and you are working on some XAML codes that is there. Pretty nice because that previewer can crash, and we have lots of crashes there because lots of components do really crazy things, but it doesn't matter because we can simply restart it and just hook up the protocol again and get the latest information from that process if it is needed. And it's nice because we can lower the memory footprint a little bit. You don't always need that previewer running, but it's also nice that we can crash things independently where needed. Having multiple view models and having multiple contributors to those view models is also interesting in case you want to have other new features. A lot of companies built their own Roslyn analyzers, for example. Microsoft ships a lot of Roslyn analyzers. Well, ReSharper does not use Roslyn. It uses its own engine, but we still want to be able to support your custom analyzers, your custom source generators, maybe. So what we do is if we detect that you have an analyzer referenced, we launch a Roslyn worker process, The Roslyn worker process subscribes to the view model as well, and will do exactly the same thing that ReSharper does, namely communicating with the list of inspections that is there, for example, and saying, look, there's this Roslyn inspection that you should show with this icon, this ID, this text range in the document, and show it on screen if you want. If you actually look at Rider, you will see that the Roslyn ones have a Roslyn icon in the light bulb there as well. And if you look at Process Explorer, when you have some Roslyn analyzers, you will see that you have Rider running. Rider is running the ReSharper host, and the ReSharper host will have started at this point also a Roslyn worker host that is analyzing your solution in Roslyn, in this case. We started thinking, since the protocol is also socket-based, can we maybe split multiple processes over multiple machines? And we started looking into Docker debugging and remote debugging, where we would take our debugger process, push it into your container, and just communicate over a socket with what is going on your machine. So the protocol can span multiple machines if you want. We actually have some examples. Remote debugging and Docker debugging are one of them, but there's more coming. The Unity game engine is another really nice example. Any game developers in the audience? Couple, cool. If you use Unity 3D, the editor, you will find that it's great for designing and whatever is there, but the coding is not as rich as what you would have in a proper IDE. So what we did was build an extension to the Unity editor, hook up the protocol, and we have the Unity editor from that plugin also communicating with Rider to make sure that we have multiple processes listening to the same thing, doing the same thing, which is actually really cool. Because this also means that you can do things like this, where you have, and I know it's very small on the slides, but I'll explain what you will be seeing. We can do things like find usages in Rider, find, for example, this button that is in the game. This button in the game will be a button that is 3D designed and created in Unity. Well, we can enrich our model with information from Unity because the plugin lives there. And we can do a find usages across IDEs. So what you will see is if you do find usages, we find that button and jump into the Unity editor because we know that button exists there. The protocol is subscribed and we can navigate back and forth between the IDE because they both subscribe to this model. Code with me. Anyone tried it? I know it's not yet in Rider. I'm sorry for that. It's ironic. Code with me is collaborative editing, where you can do pair programming and things like that. It is essentially built on top of this Rider protocol as well, where you have the host exposing everything that is in the host machine into a view model, and we have clients subscribing to that view model, contributing to that view model, and you can pair program. The irony is that it not yet works for Rider, even though it was built on the technology that powers Rider, because Rider is more complex because you always have multiple processes on the host. You have ReSharper and IntelliJ, and the client kind of has to know about that as well. But it's coming. Remote development is another one since this week. Same thing as Code with me. It has been built on this protocol. The idea is you run a headless IDE on a server somewhere, you connect to it, and you can do things with that. I will give you a nice example of a hackathon project that we did this year. So Code with me, built on top of the Rider protocol. We decided, okay, since you already have this setting where you have multiple parties working together, can we build a multiplayer game on top of this protocol and work with that? And actually, you have a nice overlay where you can play and shoot and play asteroids using the Code with me infrastructure that is there. So this is pretty nice. With audio, it's even nicer, all of those retro sounds and all of that. The idea with this one, and I'll actually show you the code of this, is we wanted to see if we could extend the Code with me model. Same approach as in Rider. You have, in Code with me, there's an IDE route. We found that we could fake the IDE route to connect to it and add something on top of the view model. And what we have there is that we have a structure that is a position, we have velocity, we have the dimension of everything that is in the game, we have bullets that are there with their position, how long they have been in the game already. We have ships that have a score, that have a position, rotation, whether they are giving power or not, whether keys are pressed, and all of that. This is in the model. We generated that into Kotlin codes. So in our code, we could work with this play with me model without having any information or whatsoever on the fact that we have this version conflict resolution underneath and all of that. We might actually release this at some point as a kind of fun plugin to your IDE. Downside right now is that we are really bad at writing game loops, apparently me and my colleague. So it's kind of slow if you have a lot of players, but it works, it's nice. Right, there is some things that we can do in the future, and there are some side effects. We already saw some side effects of coming up with this architecture for Rider, having this model. Code with me, remote development, all of those things are already side effects, but we have some other things we are thinking about that we can do with this protocol. So first of all, having multiple machines, remote development is already there. We are toying with the idea of also being able to host that WPF preview process, for example, on a Windows machine, while you may be building XAML codes on a Mac OS X machine and just connect to it and have Windows-based WPF rendering going on and piped into your IDE that is sitting there. So that's one of the ideas that we're toying with. Another big idea really is having all of our IDEs support both being a front end and a back end on the protocol. Since for Code With Me, we had to model everything in the IDE on the RD model as well. We now have essentially every IDE capable of being both a host and a client. So imagine our WebStorm, our web tooling is kind of nice in Rider. Imagine if we could run WebStorm as a backend for ReSharper in Visual Studio. So we could override everything that is HTML editing, CSS editing in Visual Studio, pipe it into WebStorm, and bring that into the Visual Studio experience. Could be cool. Not saying this is ever going to happen, but it's some thoughts that we are doing, some experiments that we are running and playing with. Modeling the view is another one. Especially for ReSharper, a lot of things are common between ReSharper and Rider. So what if we could also extend our model to be able to render UI? To describe model a UI that has actions, that has buttons, that has things that happen when you click a button. The idea is that we can do that, and we already have something there. It's not ideal yet, but a lot of the settings tool windows, for example, a lot of the settings in ReSharper and Rider are based on an experiment with this where we have a DSL where you can add headers, add text boxes, empty lines, positioning, all of those things modeled in the model. You can subscribe to it when something has to happen, and then we can render it in WPF, but we can also render it in Swing on the IntelliJ side and wherever we want to render this. So in summary, I would say Rider is an IDE built on top of two other IDEs, making it essentially three IDEs. It's a combination of the two. It's built on two technology stacks. We needed a very rich and flexible programming model to communicate between the two, which I think we managed to do. And this model also gave rise to a lot of things that we are releasing 5 years after we released Rider, which is multiple processes, remote development, Code With Me, and all of those things. So I'm not sure this will be of any practical use, this talk, so sorry for that, but I do hope it gave a bit of a view into the internal kitchen, what is going on behind the scenes when you're working in Rider. Thank you very much. And if there's any questions, of course, feel free. Yes?
You mentioned possibly being able to run WebStorm inside Rider, for example. Is that the basis for the fleet?
Good question. So the question was, you mentioned running WebStorm inside of Rider. Is that also the basis for the Fleet ID? Very complicated answer. So for those of you who are not aware, this week we also released a new experimental Fleet ID, which takes a lot of the learnings from 20 years of building IDEs into a new one. The idea there is indeed to work similar to how this all works. It's not the same, but it's similar in terms of concepts, where we have one IDE where we can run multiple backends, whether it's a language server or full-blown WebStorm or full-blown Rider to power the front-end experience that you may have in your code. So it's similar, but not the same. Hope that answers the question a little bit. Cool. Anyone else? Really hard to see, so just shout. Yeah.
Do you know when the preview of the code with me is released?
A preview of?
Code with me.
So the question is, when will a preview for Code With Me be released for Rider? I really, really hope it works. It's not perfect yet, so we have nightly builds that works. I hope in the first quarter of next year, but this is not a promise, unfortunately. But I hope it will come there. Just shout, or otherwise we'll go have coffees. Thanks.